is Julia. I'm from Brazil and I'm currently a student of PPCR 2020 Principles and Practice of Clinical Research. And finally guys, I made it. Let's do a review of Module 2 Basics of Statistics, and the bibliography I'm using is our course book Critical Thinking in Clinical Research. Look guys, I'm a student, I'm not a TA, okay? So critical thinking while watching these videos. Okay guys, in this next video I'm gonna focus on representation of data. Remember the types of data? Also we have qualitative data, quantitative data. Qualitative can be nominal, like categorizing, giving names to categories. Ordinal, so we have numbers, and we don't necessarily have numbers, but it can also be represented by numbers. But here the order matter, but we cannot count the difference between each category and the other one, right? And that is actually meaningless. Then we have quantitative, discrete data. So we have order, matter, and magnitude. The spacing between categories matters as well. But the difference between discrete and continuous is that discrete, also called count data, only encompasses whole numbers, while continuous data can encompass decimals and fractionals numbers, right? And it can also be called measured data, okay? Okay guys, so now we can go to the representation of data into graphs. So the two main kinds of graphs used to represent qualitative data is the pie chart and the bar chart. Well, so pie chart, here I can use to compare, I cannot compare like two categories with two levels. I can have like only two categories with one level each. For example, birds and cities. I can only choose one species of bird, or for example, more than one city. But I cannot say like I want to evaluate several species of birds in several cities. And in order to do that, I would have to build more pie charts, or maximize or specify this area here, for example. Okay. Bar charts, it is the same. So I can say that I have several species of birds in one city, or I can say that I have only one species of birds in several cities. Okay. Here guys, the important part, before we move to bar chart, pie chart, the proportion here is by the angle of the circle. Okay guys, so here I have an angle of alpha, I don't know. Okay. Not the area, okay? So the proportion is based on the angle, okay? Then we can go to the bar chart. It is important that since we are analyzing just like categories with one level, the bars, they have to be like the same size. The width of each bar has to be the same, okay? Same of the spacing here, okay? The space has always to be one at the same size.
Not that it is in the same size here, but my drawings are not good at all.
Okay, so moving on. Then to represent quantitative data, I can use other kinds of graphs. So the most common one is the histogram, and differently from the bar chart, I can join all the bars. Then I can do like, for example here, an ascendant ordering. And that can represent, since the bar are all together, I can represent a continuous category or continuous data, right? And a histogram is the base of a line chart. What is a line chart? So here we can draw, let me choose another color. We can draw a line chart while we have a histogram. So we pick up the upper part, the upper part of each bar, and at the midpoint we draw little points. So here, here, and here, and then we connect it with a line. That would be something more or less like that. Okay? Then we have a scatter plot. So each point represents one value in the x-axis and one value in the y-axis, but I can have like more than one plot for each x value. Okay, for example, I can have here like 2 points representing the same x value, right? That is not like each x value only have one y value and so on. That is the difference between line chart and scatter plot. Here in the line, I have only one value for each y value. Okay. Okay. So here I can say, like, I can infer that I have a distribution more or less like that. Okay. I have some points here that are not following the most of the data, but this we can call it like outliers. Okay. Okay guys, so then you can go to the box plot. First time I saw it, I was really shocked. It seems to be very difficult to interpret, but actually it's not that difficult. So first we have here a box, right? This line here represents the 25th percentile. Okay, it is like the 25th number of a sequence of a data set. So for example, if I have a data set of, I don't know, 200 individuals, my 5th percentile would be like 50%. Okay, so cut, then I'll have like my 5th subject here would be my 25th percentile. Okay, then this other line here represents my 75th percentile, and same thing. So 200 times 75%. Okay, so then I would have, I don't know, 150. So this subject here would represent my 75th percentile. Okay, and then we have a line in the middle of the box. That line represents the median of the data set. So this line divides the data set in 2 equal parts, 50% before the line and 50% after the line. And this can be right in the middle, so that would represent that our data set is normal. I'll define that in later. But if it is not in the middle of the box, for example, here, I can say that my data is skewed, so I have a median more to the left. So I would have something like, oops. So it have something like that, with a left-sided skewed data. Okay. Then I have these lines here that represent the outliers. So outliers are only represented when this space here is bigger than 1.5 the size of the box. That would represent the outliers. I can say that this box here is not sensitive to outliers because it encompasses just the 50% between 25th and 75th percentile. Okay, not so difficult, right? Well guys, I'm going to explain normal data and skewed data in the next video. Okay, so if you want to know more about it, watch it.